You should all have this page here in front of you. We are going to focus today on something called perimeter and circumference. So we just went over what perimeter means in our bell ringer. That's the outside edges of a shape, like adding them all together. But when we have a circle, does a circle have edges to it? No, not really. A circle is way different than like a rectangle or a triangle would be. Those shapes, squares, rectangles, trapezoids, triangles, they all have those straight edges that we would use to add up for our perimeter. A circle doesn't have that. Circle doesn't have edges to add up. It's like this curved thing that we have to kind of look at a little bit differently. So we're going to talk about circumference. Now on your page here, I want to go over what does the diameter of a circle have to do with the circumference of the circle. So can anyone remember or remind me what is the diameter of a circle? The length from one end to another, and it has to go through the center of the circle. Okay, so we think about diameter, we're going all the way across, like cutting that circle in half, but it's got to go through the center point. That's what makes the diameter a diameter. Because there are other things that do that same idea but don't go through the center, and they have a different name. So we need to talk about how does the diameter in a circle relate to its overall circumference. So on your page here, you have this chart. I'm going to talk you through how we're going to fill this out. You're going to go to a website today. It's going to take maybe 5 to 10 minutes. We'll get there in just a second. You'll get your computers out. You're going to go to Schoology. There's a link on Schoology. Okay? You're going to fill this out, but I want to show you up here what I want you to do so that you can then do this work by yourself in like 5 or 10 minutes. The first thing that you should do, and you can all do this right now, is you're going to label 1, 2, 3, 4, 5. You're going to do 5 different circles and looking at the numbers on it. Okay, so all you got to do is fill out that first part, 1, 2, 3, 4, 5. The next couple of columns, the diameter column, the circumference column, and that last column that says the ratio of the circumference and the diameter, we're going to have to fill out using our website. So I'm going to show you what this looks like on Schoology. Like I said, I already put a link on there this morning. So when you guys go to your Schoology page, you just need to click on our class, and at the very top, it should say GeoGebra link for today's date. So I'm going to click on that, and it'll open it for you in Schoology, or you can click on this little arrow in the box and open it up in a tab on its own if you'd rather. Okay, when you get here, you're going to have a circle, and there's going to be 2 numbers that you need. That one by the dot, that 8.36 that I have right now, that's my diameter. Okay, let's just go ahead and all fill this one out together on our chart. So for my first one here, I'm going to put 8.36. Now my circumference is that number up here where it says circumference of D, so circumference of this diameter that I'm given, is 26.26. So that's going to go in your second column. Okay, then what you're going to do for that last part is you're going to do division. You're going to put your 26.26 on the top, and you're going to put that 8.36 on the bottom. I don't want to hear the answer right now, okay? I just want you to write it down in that little box over there, and they say to put it out to 3 decimal places. So you need to have it be a number, point, number, number, number. You want 3 numbers after your decimal point, okay? I don't want to say the number because I don't want to give it away. But what I want you guys to do now is you're going to go to the website, and then you're going to change your diameter. So on here, you're going to grab the center dot, and you're going to move your circle. You can make it small. You can make it really big. I don't care what you do for these other numbers, but you need to now go do this 4 more times to fill out the rest of your chart. Once you have your chart filled out, right underneath that, it's talking about finding the average of those 5 ratios that you measured. So once you get these numbers all filled in, you're going to plug those into these boxes down here and find the average. Remember, average is when you add up all the things that you had or add up all the scores and divide by the number that you were given. So you're going to have 5 ratios there. We did the first one together. You're going to add up the other ones that you have to get your average. And then underneath that, you're comparing with people next to you. So once everyone's had their chart filled out and you've done all the math, compare your average to their average. You should see something happening. Okay, so I'm going to give you guys like 5 to 10-ish minutes to get your chart filled out. All right, if you haven't yet, once you guys get these numbers here, you're going to take these 5 numbers. They're going to come down here to these boxes. Then you're going to add them up, divide by 5 to get a number here. This is your average number that you found from up above, okay? Then what I want you to do is compare with the people at your table or someone next to you or behind you and see what they got for their average. See if it's similar to what you got or if it's super different. Okay, so take like 2 more minutes to go ahead and do that. Do your average and then talk to each other for a minute. Once you've got all your numbers taken care of, you guys can close your computers because we won't need them for the rest of class. All right, let's talk about this here. So you should have filled out your chart, okay, with all your numbers. I walked around, I saw you guys were doing that. What was this number that all of us were getting out there? 3.14. What number is that? That's pi, okay? Pi is spelled P-I in math, okay? We don't have an E. We're not talking about the pie that you eat. We're talking about this number. Now, pi is a really famous number in math. It's irrational, which means it's a decimal that never ends, and it also has no pattern or repetition to it. So there's never a section of pi that repeats itself. It's always changing and different. People have worked with pi for a long time and have studied how pi looks. I mean, there's even a website all about pi that has it out to the millionth decimal. So if you're really bored someday, you can go Google that. But this activity was mainly to show you guys where pi comes from, okay? Because in the past, you've probably had a teacher talk about pi, but you're probably like, what does pi even mean? Why do we use that number? Why is it so important in math, okay? Pi is this direct connection between a circle's diameter and its circumference. If we take the circumference of a circle and you divide by the diameter, it's always going to equal pi. Okay, so if you guys turn your page over, let's write that down. When you had the circumference divided by the diameter, we got pi. So when you guys did your chart on the other page and you did all that division, you should have gotten something that was like 3.14 and then maybe a 1 or 2 or something else. And then when you added them all up, they averaged out to be 3.14. Now we're talking about circumference here today, and there's a formula for circumference. If I wanted to solve what I just wrote up there for the C, what would I need to do? How would I get the C by itself on that formula? You would multiply by the diameter on both sides? Is that what you're saying? Yeah, because I would take this side times D so that they cancel, and I would take this side times D. So she said diameter times pi. So your circumference, one way to find it would be to take the diameter of the circle times pi. Now, what if you're not given the diameter? Sometimes on a circle, they won't give you the diameter. Instead, they'll give you the radius. Does anyone remember what the relationship is between a radius and a diameter? Brady? So radius is from one side to the middle. How does that connect to the diameter that went all the way across? It's half the diameter. So the diameter could also be maybe 2 times the radius. Or if you take diameter and you cut it in half, you divide by 2, you would get radius. So could I rewrite my circumference formula? Instead of having D for diameter, what could I replace that with to find if I had radius? What did we just say D was equal to? 2r. So I should be able to rewrite this as 2r pi, or sometimes we write it 2 pi r. These are the two formulas that we have for circumference of a circle. Diameter times pi, or sometimes that's more commonly written as pi times diameter, so I might switch that around. And then we have 2 times pi times radius. The order of those terms doesn't really matter because we're just multiplying. So we can multiply them in any order and it's not going to affect my answer. All right, so what we're going to do now is down below, they're going to give you something about a circle. Maybe they give you the radius, maybe the diameter, maybe they're giving you the circumference, and then they want you to find something about that circle using the information provided. If we look at 1 together, we are given the radius. It says little r equals 4 centimeters, and they want us to find down below circumference. Now, do you guys see after my space or my answer how it has that E in parentheses? What that E is telling you for this problem is that they want an exact answer. And what that means is that it's going to be in terms of pi. That means when we write our answer, we still want pi to be attached. We don't actually want to multiply by pi right now. If I wanted an estimation of the circumference, then I would multiply by that 3.14, or I would use my pi button on my calculator to do that for me. But for right now, I don't really want us to operate with pi because, again, that would be an approximate answer. If they want an exact answer, that means you're going to attach pi like you would attach a letter or you would attach like a square root sign if we were looking for an exact number. So for this one, because I have my radius, I would use the formula 2 pi r, and I would plug in 4 for r. Now remember, I don't want to operate with pi, which means I just need to multiply my numbers. What's 2 times 4? 8. So my answer here would be 8 and then pi. And do you guys know how to label circumference? Or how you would label perimeter? Do we do anything fancy with the label at all, or is it just whatever the units are? Is it squared for perimeter? Or do we square it for area? Area squared. If you have perimeter or you have circumference, the label is really nothing fancy. Okay, so we're just going to have centimeters attached. Make sure, though, guys, that we are labeling our answers. Labels are going to be really important in this unit. Don't forget your label. You'll miss points if you're not labeling stuff, especially on like your tests. So make sure that you're putting a label on your answers. That's the exact answer. 8 pi centimeters. We're going to leave it there. We're not going to multiply by pi. Okay, if you look at the second one, this time they're giving me circumference and they want me to find diameter. So I have a formula that has diameter in it. It was pi times diameter. And they're giving me C equals 6.5 pi. Anyone see what the diameter is going to be? 6.5 centimeters. Because these pi's are basically going to cancel. The C's are gone. Like everything kind of has something to pair up with. And so 6.5 is going to be equal to that diameter. So I want you guys right now to take a couple minutes and do 3 and 4 on your own. All right, let's talk about these here. So for number 3, you're given the radius, you want to find circumference. So you could have used your 2 pi r formula. This is very similar to the first one that we did. What'd you guys get for an answer here? Good, 14 pi, and my label would be centimeters. Okay, the last one, number 4, you have circumference. This time, though, you want diameter. So you could still think of it as C equals pi times diameter. And what would your diameter be? 15.5. But how do we go from diameter to radius? Divide by 2. So what's 15.5 divided by 2? 7.75. Now you don't have to use the diameter formula there. You could have used the 2 pi r formula. You'd still end up, though, taking 15.5 divided by 2. That's unavoidable. You have to divide that in half because that's not the radius. So make sure when you're working with circumference especially that you watch carefully down here. What do they want you to find? Because if you need to find the radius, you're going to end up dividing by 2. If you just need diameter, you won't have to do that step. All right, now let's go down to the last couple of problems here. We're going to find perimeter or circumference of these shapes. Again, they want answers in exact form if necessary. That just means if pi shows up, we want to keep it as pi. Now, some of these are missing some side lengths, and so we have to maybe do some reasoning through this to figure out what these missing numbers would be. Can you guys tell me, first of all, what's this one going to be? 2. Those dashes still mean congruent. So if this other side here has that dash and it's 2 centimeters, that means that this side is also going to be 2 centimeters. That takes care of that little tiny piece, but I also need the bottom here and I need this right side. How can we get there?
The right side is 9.
How'd you get 9 here?
Because it's shortened by the 2.
Mm-hmm. So you took 11 minus 2.
Yeah.
So this side's 9, and I'll just put next to that 11 minus 2. Okay, how about the bottom? 6. Same reasoning?
Yeah.
Yeah, we're taking 8 minus 2 for that one. Okay, so then how do we find perimeter? Add all the sides. So the sides are 8, 2, 2, 9, 6, and 11. And what do we get? 38 centimeters. Very good. If it helps too for some of these to split it into smaller shapes, you can do that. Like you could imagine lines in here to like cut it into smaller rectangles if that's helpful to figure out side lengths. And we might need to do that for some problems like this next one here. This shape on 6 has 4 sides, but I only have 3 of the 4. I'm missing that last one. I can't use anything right now like we did on the previous problem to help me get directly to that last side. Like I can't take 18 minus that 10. Those are not relating to that diagonal side there. But if I do draw in a line here, what did I just create? Okay, what kind of triangle? A right triangle. Now, can we figure out how long this side is of my triangle? 6, because it would just move over. How long would the bottom half of my triangle be? 8, because you could just take 18 minus that 10 from up above, because the 10 goes to where I created my triangle. So this side would be just here to here would be 8. What could I use to find the diagonal? We know it's a right triangle. So what do we know about right triangles that help us find sides? Well, you could use tangent if you want to, but you don't know those angles. Or something else. Pythagorean theorem, which says what? A squared plus B squared equals C squared. Okay, now just to give you guys a warning, Pythagorean theorem is going to show up a lot in this unit. We're going to have to do this process a lot of times when we're finding perimeter, when we're finding area, when we're dealing with shapes that are kind of like being blended together. And a lot of the times when we see Pythagorean theorem in this unit, they're going to be what's called Pythagorean triples, which are perfect pairing of numbers that will always work inside of Pythagorean theorem, and you won't be dealing with decimals. This is one of them. 6, 8, and then the third number makes a Pythagorean triple. What is the third number? 10. 6 squared plus 8 squared is going to be equal to 10 squared. Okay, that's one example of a Pythagorean triple. Another one that you're going to see a ton of in this unit and even in the next couple of units is the 5, 12, 13 triangle. 5 squared plus 12 squared always will equal 13 squared. So if you start to recognize some of these numbers like 6, 8, 10 always work on a right triangle, 5, 12, 13, you don't have to show me this work. Some of you are going to start to see them all the time that you'll just know it. Okay, so we know now that this side is 10 from our Pythagorean theorem. So how do I find perimeter of this shape? What are all the sides? The outside sides. So 10, 10, 18, and 6. And how much is that? And you sit at that table there. How much is this?
44.
Good, 44 centimeters. Okay, we've got one more. What shape is that? Semicircle? Half circle? Okay, so we're dealing with a semicircle here, which means we have to now go back to circumference. So let's think about how we would do this. Circumference of a full circle would be either pi times diameter or 2 pi r. This 8 centimeters is giving me what? Diameter. So I'm probably going to use pi times diameter here. But remember, that's for a full circle. You're telling me we have half of a circle. So what do I need to do? Divide by 2. Okay, so let's do this. We're going to take pi times 8, and we're going to divide by 2. And how much is that? 4 pi, right? Okay, now hold on because we're not quite done. A circle's circumference is that curved part of it that goes all the way around. So what is that 4 pi referring to on my picture right now? What part of the circle is this referring to? It's just the outside edge. This 8 is not included in that because this 8 was not part of my original circle. If I had the full circle in here, this green line would continue down here and it would make the other half of the circle. So this 4 pi is only talking about the green line on my screen up here. And it's not even a line, but that green curved part of the circle. So what do I need to do to get the full circumference? What do I need to also take into consideration here? We don't want to times by 2 because I'm not dealing with a full circle. But I want to find like perimeter here. I want to add up all the sides. What's the other missing side? The 8, the bottom. So if this 4 pi only refers to my green part of my circle, I need to also add in the bottom that I have with my diameter here because this was not part of my original circle. So I need to take 4 pi plus 8. We cannot combine those together. You can't make that 12 pi or try to multiply the 4 and the 8 and get 32. It doesn't work like that. So we have to just say they're separated and we put centimeters on the end. So when you're dealing with a circle and you're not dealing with the full circle, if you have a part of it, you have to make sure that you add in those extra sides that created the half circle, or if you're dealing with like even a smaller fraction of the circle. All right, I am going to get you guys a worksheet here.